In this example, we will rationalize the denominators of several radical expressions. In part A, we have root 3 over root 11. We want to remember to rationalize means get rid of the irrational component, or in this case, get rid of the square root. To rationalize the denominator means our attention is solely focused on the denominator. So to rationalize the denominator, I need to ask myself, what do I multiply the square root of 11 by to turn it into the square root of a perfect square? Well, I know 11 times 11 is 121, and 121 is a perfect square. But to make this happen, I need to multiply the denominator by a root 11. Root 11 times root 11 is root 121. But as with any fraction, if I multiply the denominator by root 11, I must also multiply the numerator by root 11. We'll come back and clean up the numerator in a second, but we're going to finish out the denominator. We chose to multiply by root 11, so that root 11 times root 11 would be root 121, and the square root of 121 is 11. So we've now rationalized the denominator, but we do need to figure out what the numerator is. Root 3 times root 11 is the same thing as the square root of 3 times 11. That's how we got the 121 in the denominator. And 3 times 11 is 33. So our final version of this expression with its denominator rationalized is root 33 over 11. In part B, there are several ways you could approach this expression. We are going to begin probably in the same sort of way. We need to figure out what do we need to multiply the denominator by to turn it into a square root of a perfect square. One option is to do exactly what we just did. We multiply by root 12 so that we end up with the square root of 144 in the denominator. And the square root of 144 will simplify down to 12. That will do what we need it to do. That will rationalize the denominator. But we need to, in turn, if we multiply the denominator by root 12, we need to multiply the numerator by root 12. Following through with the work up in the numerator, 6 times the square root of 12 is 6 root 12. While there's nothing wrong with this approach, we do need to continue simplifying that numerator. The square root of 12 is the same thing as the square root of 4 times the square root of 3. And we can simplify that further. 6 times the square root of 4 is really 6 times 2. So up in the numerator, we really have 6 times 2 times root 3, all over 2, which simplifies, and this simplifies further. 6 times 2 is the same thing as 12. So we really have 12 root 3 over 12. And finally, 12 over 12 can reduce. I can cancel the 12 in the numerator with the 12 in the denominator, because the 12 in the numerator is connected to everything else with multiplication. So canceling those out to make 1s, 12 over 12 is the same thing as 1 over 1. Our final simplified version of this is simply root 3. This was not the only approach we could have used on this one. It had the advantage of rationalizing the denominator was straightforward, but there was more work to do to simplify the numerator. Another approach that we could have used on part B would have been to do this. Going back to the beginning, we started with 6 over root 12. Instead of just multiplying by root 12 over root 12, I could have instead said, is there another multiple of 12 that is also a perfect square? 36 is a multiple of 12, and 36 is a perfect square. Had I gone this route, I could have simply multiplied by root 3 over root 3, because 3 times 12 gives us that 36 in the denominator. And the root 36 in the denominator would simplify down to a 6. Up in the numerator, 6 times root 3 is 6 root 3. You'll notice by having picked a smaller radical to rationalize the denominator with, we had less cleanup to do later on. We do end up with the same answer though. In this case, we have 6 root 3 over 6. Again, the 6 over 6 does cancel to make 1 over 1, because that 6 in the numerator was connected by multiplication, and we do reduce down to the same value, to root 3. Each student individually needs to decide, would they rather simply multiply by whatever the radical in the denominator is to rationalize the denominator, but you might have some extra cleanup to do, or would you rather stop and think about what's a smaller perfect square that's a multiple of the denominator's radicand, and then do less cleanup later? Either way, as long as you're doing the work correctly, you'll arrive at the same answer. But don't forget, if you multiply by whatever's there to begin with, like we did in the original approach with root 12, you might have a radical that you do need to simplify.